and async load your questions. So I'm Vance, vancelucas.com, Twitter @vlucas. I'm right here in Oklahoma City. Christian, if you have any questions about that, happy to answer that. Work at Oracle right now. I worked at NetSuite, but Oracle bought NetSuite at the end of last year, so I'm on the team at Oracle there. We're building a CMS all in JavaScript that sits on top of one of their other products. So been entirely JavaScript there, and it's required me to learn a lot for probably a little over 2 years. Had to learn a lot, really dig in, and that's kind of what this presentation is. It's kind of a story of what I had to dig into and how I had to learn all this stuff so I can then share it with you guys. ThunderPlains is a conference I co-organize with Jesse and Amanda Harlan, who brought food, so awesome. And Techlahoma, obviously, is this. I think you all are aware of everything that Techlahoma does. If you're not, techlahoma.org or donate.techlahoma.org if you're interested in supporting Techlahoma's mission of having these user groups and paying for the space and the food you're eating and things like that. So that's my little Techlahoma pitch. Okay, so your browser is your JavaScript IDE. JavaScript. Most people probably don't use an IDE with JavaScript. Maybe you do now because Visual Studio Code is out and stuff like that, and that's pretty cool. But the browser is the primary JavaScript runtime for everyone, just by nature of how it works. Obviously, JavaScript is everywhere. And because of that, a lot of the top companies in the, a lot of top tech companies in the world have been pouring just millions of dollars into JavaScript and making it faster and improving performance and debuggability. So the end result of that is basically everyone gets to benefit from all of that work. So you get to benefit from, the $100 million Google probably spent over the last, 5 years on Chrome, making V8, making JavaScript faster, stuff like that. And then the profiling tools, Google, Mozilla, Microsoft, and Apple are really the big four in the browser market. There's a few small others, Opera and I guess now Brave and some other startups. But basically, everything's built in your browser, and it's actually a better debugger than you might realize. It's actually even a better debugger than some full-blown IDEs. So we're going to go over what all is in it and what it can do. These are the four main ones I mentioned. All the examples and screenshots are from Chrome, but you can do all of the things I'm showing you in any of the modern browsers. So this is what I'm going to go over. This is kind of the major areas of the developer console. If you enable the developer console and then open it, these are kind of the major tabs you're going to see. Some browsers call them a little bit different things, but they're more or less the same kinds of major things. So I'm going to go over them in the presentation really quick in slides with some screenshots, and then we're going to move to a demo app, and we're really going to dig in, and I'm going to show you exactly how these tools work. So for element inspection, I'm sure almost everyone has probably used, well, let's go back to the list for a minute. Almost everyone has probably used the console and the element inspection. Raise your hand if you use the console or the element inspector. Like, I'm sure probably everyone, right? That's probably 10 to 20% of what the developer tools actually has in it. So that tends to be the most used, 10 to 20%, but that's really it. So surface level, you right click on something, you can inspect it, see the source. This is really useful for JavaScript apps that don't render like server side, so you can't view source, you have to inspect it as it is in the DOM right now. I'm not going to go over this too much because everyone's probably familiar with this. What you might not know, let me see if I can, the picture's not getting bigger. I'll show it to you in the browser though. But you can set a breakpoint on that DOM node, if you didn't know that, for whenever something in that DOM node changes, or and a lot of different things, and we'll go over some of that. But that will basically That's part of the interactive debugging that's built in browser. So that'll basically pause script execution and let you inspect what's there and poke around in it. Console. You can do some cool things with the console. So if you see a screenshot of something on the internet, like a Facebook post or a tweet or something, don't take it at face value, because unless you get like a link to that tweet or an archive link or something, because you can pretty much do anything you want with the console, especially, and it's especially easy for sites that have jQuery exposed. And I just popped open console, typed $sign to see if jQuery was there. It was, and so then I just changed the text of the tweet and then took a screenshot. So super easy to do. Don't be fooled. All right. Debugging. Debugging is probably the best thing about this. There are several parts to that. The first part I'm going to show you is just source viewing. So that Chrome has a source tab, and like I said, a lot of the other browsers have a similar tab. It just might be named different, something different. This is going to be your JavaScript source that's loaded, so you don't have to like go back to your editor or something, or view source and try and view it. You can view it right in there. If it's not formatted code, they have this little button down here in the corner that I'm moving my mouse on, and it will pretty print the code for you. So if it's all mushed together or obfuscated or something, if it's obfuscated, you're still going to have obfuscated like variable names in it, but it'll at least pretty print it out so you could see the code pretty good. And then the network tab is another one probably most people are familiar with. If you get like a 404 error or something in console and you click it, it usually takes you to the network tab, and you can view kind of what's loading, when, and that kind of stuff. So the problem we had at work where I had to dig into this stuff kind of started in the network tab. So we had this issue come in and say, this client site is loading really slow. Can you take a look at it? And I'm like, okay, well, let's open the network tab, see what's going on. This is kind of where I start to see, is it the network that's slow? Is it the server that's slow? Is it my JavaScript that's slow? Kind of identifying which point is slow so I can debug it further. And basically what was happening, let me zoom in a little bit. Okay, so we have this first API call here that we're making, and we actually have a second API call here that we're making. These two API calls are actually made one right after the other. So it's really weird that there's almost a second between them. It's like 3/4 of a second, so 750 milliseconds or so delay between the two calls. So my first question is, your first question might be, why aren't these two calls combined if you're making them together? And that's a good point, and we're working on that. But besides that, why is there this big delay on two calls that are made one after the other, and what would cause that? So I start digging in to the code to kind of try and answer this question. And I said at the beginning, our product is like built on top of, we're building a drag and drop CMS on top of an e-commerce platform. So some of these scripts are ours, most of them are not. And the whole page is loading as well. So a lot of the stuff is stuff that's on the page, stuff that's loading, kind of that. So, oh, I'm still zoomed in here. There we go. So let's take a look at the timeline. Then I'm like, so if these two scripts are delayed, these are async operations. If you're not familiar with JavaScript's execution model, it basically means we're firing off an AJAX request, and then we're going to get the results of that and do something later. So when you see a delay like that in an async operation, it basically means the event loop is getting blocked. So some code is blocking the event loop somehow to prevent this async call from coming back in a timely manner. So I'm going to dig into the timeline and figure out what the heck is going on. And I saw this timeline and was like, oh my gosh, what are they doing? So we'll zoom into it a little bit. And like I said, I have screenshots in this part of the presentation, but we're really going to dig into it in an interactive way right after this. So screenshots are just going to overview what I'm going to show you, and then I'm going to show you what I'm going to show you, and then I'm going to show you. If that makes any sense at all, probably not. But from this screenshot, we see these. You see all these red bars here at the top? This green graph is frame rates. So this is FPS, and see it drops to like nothing. And this red bar here is basically Chrome telling you, hey, you're blocking rendering here. You've dropped your frames, nothing's going on. This is similar to if anyone's like played a video game or something, and you're like playing it, and you're into it, and then all of a sudden it's like, and you're like, what the heck? You know, it's dropping frames, and it causes everything else to just delay execution and pause, and it's just a horrible user experience. So this is surprisingly easy to do in JavaScript because of its execution model. So don't do this to your users like we do. I'm kidding. This was development, so they've since fixed this. But there's several things to note here. The main one, like I said, is the frame rates that you want to watch. There's a flame graph here. Has anyone ever read flame graphs before, or is familiar with them? Okay, so a flame graph is just like a function stack trace that you're reading down. This function at the top is called, then it calls the next function, calls the next function, calls the next function, calls the next function, and it kind of tapers down like a flame until you get to the last thing that's called. And we'll take a look at those. This is, if you have the memory check mark checked in Chrome, you get this memory graph. And this is showing you what's in the JavaScript heap, what's currently going to be executed, how many nodes you have on the page, and how many event listeners you have attached, stuff like that. So, and you can get a snapshot of that. I have the dots right here. This kind of moves along with your mouse. Wow, it's kind of moves along with your mouse, and then you can look at the raw numbers down here, wherever your mouse is positioned. And then at the bottom, you see most of our time spent loading this page is in script execution, which is actually really bad. You want most of that time to be white, which means idle. And I'll show you more about that. So those are things to look for. You can also take profiles. So this is a profile tab. And what a profile is basically a snapshot in time of memory in the browser. So it's how your browser is using memory. It's like a snapshot of what is currently in memory, the objects, the variables, things that are taking up space, and then you can sort those. I've sorted those by size, and then you can dig into those. This is just a jQuery XHR response object that's taking the most size because they hold on to it holds on to everything. So we'll switch over to demos here. I have a few screenshots. Like I showed you, this is blocking, and then the things again, red bar. Most of our time here is spent in scripting. This is from my demo app I'm going to show you here in a minute. And this is event-based. You see little tick marks every now and then, but most of the time is actually idle time in the browser. So it's not really blocking anything. If you're debugging memory problems, this is basically retaining DOM nodes in the DOM. This can happen easily if you're attaching, especially with event listeners. So if you're attaching event listeners on a DOM node and you're leaving that DOM node in the DOM and you try to clean it up, like you remove that DOM node and you didn't unbind those event listeners before you remove that DOM node, it's actually not removed in memory. It's removed from the page, but it can't be garbage collected because you still have event listeners attached to it. And this is probably the #1 cause of memory leaks in the browser is events. and what they're attached to. This was a very common problem, and probably is still in Backbone apps. They would render a view and attach a bunch of events on it, and if you didn't call Backbone's remove, and if you wired up events in a custom way instead of only with Backbone, and you removed that view or blew it away or something, then you could still end up with that whole Backbone view still like alive as a zombie view, just not anywhere in sight, and you get this progressively slower and slower app. So these are kind of the things. These are like the official classifications. So memory leaks are progressively worse over time, stuff you're not cleaning up. Performance delays and pauses is usually due to garbage collection. What this means is you're having so much stuff in browser memory that you're forcing the browser to do a garbage collection. And when the browser does a garbage collection, it has to pause execution because it can't garbage collect when you're adding more stuff in memory. So it has to pause execution, do its garbage collection, and then resume. So if you're in a situation where you see frequent performance, like it's just freezing, or there's like a lot of jags in your UI or jank or something, and you can't figure out what's causing it, it might be due to garbage collection. You might just be having too much stuff. And then performance consistently bad is just classified as memory bloat, and that's just like everything's bad all over. So these slides are on my GitHub if you wanted to check them out. And there's a link to them if you wanted to look at them later. Now we're going to demo. I've had this open for a while. Okay, so this is my little demo app. I've got a counter at the top you can see running, and I added this counter because I wanted to show you something that's live and updating on the page, so that if we do something that's blocking, you can see how that affects interacting with the page and the user experience overall. So we're going to start. We'll probably start with the fun stuff. I made this. Well, I'll show you actually. I'll show you blocking, non-blocking. So this is blocking JavaScript. Again, note the counter up at the top. I'm going to hit that. The counter stops, and then it resumes. And why does that happen? That's because the counter runs on a set timeout, which uses the event loop. And the blocking JavaScript blocks that event loop from running until whatever is happening is done. So we're going to take a look at that in the timeline. I'm going to block, and then we'll get a timeline of that. And you see that script execution there. Let's see. I'm going to move this over a little bit more. Yay, responsive design. Okay. So we get that big nasty red bar. You see the green area over here on your FPS. It's like telling you you have none. You can click here, and if you hover over this, you see 1 FPS. That means that's really, really bad. Okay, you want to shoot for 60 FPS. If you look over here, you'll see. Let's see. You'll see. Think of a time when it's like not parsing. I'm trying to get it good. Yeah. So like you want 60. Sometimes the browser will jump in like crazy hundreds of FPS, but 60 is what you want to shoot for. That's like unnoticeable lag, even, consistent kind of stuff. So first of all, you can interact with the timeline. You might see this chunk at the beginning and wonder like, what's that? That's the browser loading our JavaScript and parsing it. So you're never going to avoid that. You're always going to see this mash in the beginning. That's the browser has to download your JavaScript, parse it, and then run it. And so that's what that beginning is. And then you can interact with it. So we can zoom in on this, and then we get our flame graph. So I'll scroll down here. So it starts with our event click, which calls the React. This is a React-based app, so it bloats it a little bit, but it was easier to do some of the stuff, so I went ahead and did it. So this is kind of steps through React's synthetic event listener. We don't have to do too much. But you can see these sleep calls. So I have this function called do blocking thing, and I can click on it. And when I do, down here, if you notice, I'm going to close the memory for a minute. Down here, if you noticed, when I clicked on do blocking thing, it actually gave me a link. So I'm going to click that. And it's going to load the source code of the page. And this is transpiled source code. So it doesn't look super nice, but you can still kind of read it. Where you can, I've got a sleep 5,000, right? That's obviously where the problem is. Never do that. Obviously, this is done for the demo. You can load a source map, though. And we can... let's look at sources. So with a source map, is anybody familiar with source mapping? Okay, so basically if you have a JavaScript application that is a bunch of files like combined together in a bundle, you can generate what's called a source map. And this tool will probably do this for you. Grunt, Gulp, whatever, Webpack, whatever you use will do this for you. And it's usually an option like a debug true or source maps true or something like that. So if you generate a source map, that basically tells Chrome in this compiled JavaScript stuff, the source actually looks like this. And then it helps you debug stuff. So we can dig in here. Notice I have like folders and things that I can dig in here. This is the blocking. So, and you notice how these are italicized, the file names? This tells you it's from the source map. So it says, and the source map is full of information, not only what's in the file, but like where it is on disk and stuff. So it looks like I'm browsing through the file system. I'm actually not. This is all in memory in the source map that was in the bundle that was created. And again, this is not only Chrome, if you use Firefox, which is awesome, by the way. So, oh, Firefox, I didn't mention this. It was in the slides, but Firefox has a developer edition that has new features that are in it just for developers, more advanced stuff. Don't have time to get into that today, but it's really cool. You should check it out if you're in the area, if you have Firefox, if you like that. So. And then you can see all the other files here. So you can really go and do anything you want, debug whatever you want. Okay, so now let's look at let's look at an event-based thing. And you see the timings there also. I mean, this is just chock full of so much information that if you know how to look at it, know how to read it, the timeline and all that, you can really see where your app is slow. And obviously this is telling me, I'm calling sleep here, but it's this is actually really slow. This for loop calculating dates is what's causing the slowdown. So we can pinpoint that and remove it in our application and make it fast. There's one more thing I want to show you. So beyond source maps, Chrome has a feature that actually lets you map your local folder and load it inside Chrome, so you can not only debug issues in Chrome, but you can actually edit the files in Chrome and then save them and then commit them later on. So that's what it's asking me here. It says, do you want to map this resource? I don't know if you can read that, but do you want to map this resource to workspace? And then I'll do that, and I can establish a mapping. And let's see, that is blocking JS. So it's looking at my local file system, and now notice these. Let's see. That did not work right. Okay, well, we'll do it. There it is. Okay. Okay, so I established the mapping, which added that local file. According to the source map, it said there's an SRC folder there that everything's in, and it looked for that file locally, it found it, so it just did everything for me automatically. If it can't find it, it'll bring up a box, which is what I was expecting, though you can actually select a folder. So I don't know if it remembered it from when I did it before this presentation to make sure it worked, or if it found it automatically, but you'll be able to do that. And notice these aren't italicized anymore. So this is an actual file now, and you can actually go in and change it and then save it. And I don't know, let me make sure. Let me make sure it was watching that. Yeah, it should have rebuilt it. Okay. We'll do a reload, see if that worked, and then we'll block, and it does nothing now because I edited that code right in Chrome. So you can not only diagnose, find, debug issues, you can also fix them right in Chrome. So really, really cool stuff. How many people knew Chrome could do that, or a browser? Okay, a couple people, right? But really cool if you don't know. All right, so now we're going to take a look at our append loop, and we're going to look at some code here as well. Let me put this down for a second. Okay. Can everybody see this okay? So this is the function that we're going to execute. Yes?
I have a quick question about that.
Yeah. Sure.
So if you have some
Yeah.
code.
Yeah, that's what I checked for. You see this tab at the bottom? It says Watcher. It's watching for local changes in the JavaScript and then recompiling. That's why I switched over to it and made sure it was watching before I reloaded and looked like an idiot for it not working when so it's just to save me that look. So this is what we're going to click. We're going to click an append, and yes, I've put jQuery in React. Okay, don't do this. I did this for the demo to show you. Okay, so we're going to look for our element that we want to append things into. We're going to create a bunch of items in a loop, and then we're going to append them. The current items num is set to 1,000, so we're just going to do this 1,000 times and see what happens. So this is a really naive implementation. Just loop over, create a bunch of stuff, and append it in the DOM inside that loop. How many people think this is a good idea? Okay. All right, let's do this. So I'm going to reload, and then I'm going to hit append jQuery. And was anyone looking at that counter at the top? We got a little pause there, right? And we see on the graph, sure enough, we got some blocking here. Our frame rates went to almost nothing. And that's almost a second, so we got one frame in that entire block. So nothing else is updating. So if you have any network calls that are going out, going to be blocked. If you have any set timeout calls, going to be blocked. All that stuff. And then we can dig down, we go, okay, so it's slow, I see that, but why is it slow? Okay, so that's what the flame graph is for. Now we're going to look at the flame graph, and we're going to go down. We see handle, append, jQuery, click, and then we see all this stuff here. Let's take a look. So these are actually, we're looping 1,000 times, remember. So we're calling jQuery's append inside that loop. And turns out that's a really bad idea. Because basically what we're doing is we're mutating the DOM 1,000 times. And anytime you mutate the DOM, the browser has to reflow or show that DOM mutation. So if you're doing a bunch of DOM mutation inside the loop, that is always going to drop your frames and cause jank and lag and all that stuff. So, so how can we optimize that? Does anybody have any ideas on how we might change that? Yes, Waylon. Turn it into one DOM modification. Exactly. That's exactly what we're going to do. So notice we have the append operation in the loop. Now we're actually, and I switched it to vanilla.js, which is just plain JavaScript. It's not a framework. So I'm creating the elements, and then I'm creating a container div, and I'm appending the items inside the loop to the container div, and then at the end of the loop, then I'm appending it to the actual DOM. So we're kind of building it in memory first, and then appending it to the DOM, which we'll see the result of here. So I'm going to reload, and we're going to do append vanilla.js. And already you can see that happened a lot faster, right? If you're watching the lower corner here, you can see those items actually came through a lot faster. It looks like, even though it happened faster though, all the graphs look better. We see some white here. It's not all scripting anymore, but we still have that blocking. Let me do that one more time. There we go. Okay, we still have that blocking though. And while it's not as bad, and it was faster, we get 5 frames per second now here, it's still not maybe as fast as we could go. So let's see what happens, what we can do with this, and let me do this. I'll do the jQuery append, and then I'll do the vanilla append. Hopefully we'll get them in the same profile. We did. Okay, so there's the difference between the two. You can see that's a really big improvement already. Like if we shipped that and we told our boss, hey, I sped it up 5 times, that's like, great job, you know? And so we already did really good, but we're still blocking. So, which still means if we're sending any outgoing network requests or anything like that, those are going to be blocked as well. Incidentally, this is exactly the problem that I found when I was debugging the stuff for work that I was on. We just had a render, a loop, items, like basically backbone views getting appended in a loop, which was terrible. But we couldn't have found that without digging in. So we're going to do it async right now, and really all I'm doing is setting that in a timeout. And it's like, okay, well, that helped some still, right? It takes approximately the same amount of time, it looks like, roughly. This is not a scientific measurement, but just from the timeline, it looks roughly as big, but it didn't block the whole time. So this is interesting. So let's zoom in here. So we actually only blocked a little less than half the time, and then you see all this work that happens out here. So let's take a look at the code that achieved that. It's a little bit more hairy when we do async. And in a for loop, all we're doing is we're creating an updater function that's going to actually append everything to the container, and we're putting that in a set timeout, and then we're doing a final set timeout to append the actual DOM node. So this is a little bit better, but we still have some blocking going on that we can see. So let me drill down here. So you see about some of the operations happened in here. These are all the set timeout calls, and then outside that stack is where everything actually got appended. So our async worked. The next tick, you know, it did all our work. I'll contrast that. If you remember the previous graph where all of this stuff was like at the bottom of the flame graph and it was bigger, so improvement. Now we're going to use something called request animation frame, and this is not really a performance talk, but I thought it'd be cool to dig into not only how you can diagnose issues, but how you might actually solve them for you guys. So I hope this is not too far past the only browser tools section, but it's really cool, I thought. So request animation frame is, has anyone ever used request animation frame? Okay, a few people. Basically what request animation frame does is it gives a function to the browser and says, run this function whenever you're ready to update the DOM. So instead of saying, update the DOM right now, append this thing right now, when I say so, it's like, okay, you can update the DOM with this function whenever you're ready. And so what that does is that basically, once the browser's done all its garbage collection and clean and cycle, then it can paint all your stuff when it's ready to. which results in a little bit better executions. How many? Do you think this is going to go faster? How many people? Faster? Yes, faster. All right. Okay. So actually, check this out. Actually, it's still running. So what's going on? Like this timeline looks way better. Like there's no blocking anymore. You see our frames. We're doing a bunch of updating here, but our frames are still, 58, 63, 59, 59, 49. They kind of dip in and out, but they're about, they're about where you want them to. So what's going on here? Why isn't this faster? Well, request animation frame is pegged at 60 FPS. So what we're doing here, I'll show you the code. I actually should show the code first. I'll do that next time. So what we're doing here is, I'll show it. It'll be easier. We're requesting an animation frame with our updater function, and we're passing in the initial value. And then our updater function, request animation frame takes a function, so we're going to return it the function that it needs, and it's like set timeout. Like it needs a function, but we need to pass it a variable, so we have to do like currying to do that. But the important thing is here, instead of doing like a while loop, we're going to request another animation frame with the next number, and we're going to append that in the next animation frame, and we're going to keep going until that number that we're passed in, we pass in 1, plus 1 each time. We're going to keep going until that number equals our max item nums. It's effectively the same as a while loop, but this is in each cycle of an animation frame. So if we're pegged at 60 FPS, we're appending about 60 elements a second, or so, whenever this runs, however fast the browser's running this, which is okay. It doesn't cause any blocking. It's perfectly smooth experience for our visitors, but it's actually not as fast overall. It takes a really long time for that whole thing to do, and I think it's faster than 60 a second. But anyway, you get the point. So we have kind of a unit of work that we're doing each frame that we get from the browser, each time the browser says, I'm ready to update. And then we're doing something in that frame. So what if, does anybody know how we might make this faster with request animation frame? So request animation frame can actually go faster. We can make this faster. What if instead of updating one element, we updated several? Let's see what we can do. So I've modified our updater function and added a for loop, and I've added a second parameter, number to update, and I'm passing in 100. So now we're going to update. We're going to append 100 DOM nodes at a time inside each request animation frame. So let's see what happens now. Let me scroll back to the top here. All the way back up. Okay. And then we'll do faster. Wow, that actually happened a lot faster, right? And you can see the work being done here. Here's all our work. Look at these frame rates. 69, 73, 66. Like, wow, this is impressive. So all of a sudden, we get a faster speed than a loop. We get no blocking, and we get all our elements appended. Pretty good stuff, right? Do you guys think we can go faster than that? Let's try this first. Let's try this. What do you think is going to happen if we update them all in a single animation frame? Let's see if they'll do it. Okay, so we're just going to shove items num as the constant. That's 1,000. So we're just going to say update everything in a single frame. Is this going to be faster? I'm going to click on it again, and we got them. Looks like no. Sorry, Waylon. Sorry. You can get a Pepsi, though. So it looks like we're actually doing too much work now. So we've kind of hit a limit in what you kind of have a certain amount of time to do all your work in with request animation frame before the browser says I'm done with the update cycle. If you do any more work beyond that, you're kind of blocking that. You're extending that browser cycle out a little more than you should be. So it actually ends up being slower. So if you're using this, and this isn't like an animation talk, but if you're using this, it's just like a game loop, you know? Like if you do too much work in a single cycle of a game loop, you're gonna effectively pause the game or hold up all other updating, pause execution, all that kind of stuff. So we've actually probably, with 100, you can do a little bit of experimenting with your own code. It really depends on how much work you're doing in that loop. But with this code, probably 100's really good. Now you can go to your boss and say you got like a 20x speed up with no blocking, and then he'll really be happy. So, or she. Okay, so I think that's it. We have a button. We have a button even faster. Chad says this will go even. Whoop. Chad says this will go even faster. Let's check it out. Stop. We've gone plaid. So actually, request animation frame is about the fastest we can get because it's you telling the browser do work when you're ready. So there's some fancy things you can do with like service worker offloading work and stuff like that, but there's really not much else you can do to speed up the browser. I mean, you've got to render those things at some point, and it's gonna, you're gonna have scripting cost incurred. You can't eliminate it. You can just kind of do your best to not block. Yeah. No question. Yeah, it could depend on the client as well. So with JavaScript, if they're on mobile, maybe that's not 100 items, maybe that's 50 or something. It just depends on your workload too. If you're if each loop, that's really saying do 50 loops of the whatever. So if inside the loop of whatever you're doing some heavier work, it could be just 10 or something. But the important thing is it won't be blocking, and that's with JavaScript. Sometimes you have to make some trade-offs. Like it's not all programming really is trade-offs. So you kind of have to choose. With request animation frame, it actually ended up being our shortest thing. But if you run into a situation like that on an underpowered device, you might actually have to make it take longer so that it appears to be faster. Because if you block, people aren't going to be able to scroll, they're not going to be able to interact, they're not going to be able to do anything else, and then they're going to say it's obviously slow. But if you make it to where it's not blocking, then it will appear to be fast, even though the actual total number of milliseconds is slower. But as long as it stays responsive to the user and to user input and stuff, as long as you don't block, it will seem faster and it will feel faster. Does anybody have any questions so far on any of this? Yeah. How do you tell the browser how long the profile is? Well, if you go to, let me just reload without being in timeline. So if you go to timeline initially, no, it's not cleared. Let me clear it. It kind of tells you, it says hit Control E to start it now, or you can, while this panel is open, hit Control R, which is what I've been doing. I've just been reloading, which automatically starts the profile. And then when it kind of senses that no work is being done anymore, it kind of ends on its own. If you want to take a more measured analysis, though, you can. Oh, there actually are a few more things I can show you, but I'll do this first. So I'm going to hit Control E now, and then I'm going to click on everything, and I'll show you what this. Control E, click, 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 and I'm not going to click the last one because that was just silly. And then I'm going to kind of wait, and then I have to hit, when you hit Control E, you get more control of it, so you have to hit stop. But now we can compare them all. This is the first one, jQuery. This is the vanilla. This is async. And then all the rest of this is request animation frame stuff. That's kind of how you get more fine-grained control of it. there's one other thing I wanted to show, and that is memory. I kind of closed it from the beginning, but this actually gives you some extra information here. So we're going to focus on this right now. Okay, so this is the heap. Now these lines, these are pretty jagged. Does anyone know what this is telling us? What's going on here? Waylon knows. It doesn't. You are writing a bunch of DOM nodes, but if you, yeah, go ahead. Yes, it's garbage collection, because you got a little hint with the. That's what you're going to say, Waylon, right? All right. The JS heap is blue. These are color coded. So this is each time the browser has to do a garbage collection. There's actually quite a lot of garbage collections here, and that's one of the reasons why that we're blocking so much. And then nodes, we're appending all these nodes, to the DOM. So the number of nodes continues to go up and to the right, just like your startup's profit curve. And in our vanilla JS, we still get some garbage collections, but not nearly as many. Why is that? It's because jQuery's parse HTML is actually pretty expensive. We were naively throwing some HTML in there that we expected jQuery to parse and create an element out of, and it's actually pretty expensive to do that. So the vanilla JS, we're doing document create element instead, and that actually saves us quite a lot of memory that we're not having to use, and so it's not having to garbage collect as much. And then over here, you see some small ones, but again, not much. You can actually force a garbage collection also by hitting the garbage can icon here. So if you have your timeline open and you're recording a timeline or doing something, you can actually click it and you can force the garbage collection to see what happens in your app. So you can do some pretty cool stuff. And you can throttle the CPU and the network and stuff like that. So if you were shooting for like a mobile device or an underpowered device, you can actually throttle to make sure your JavaScript's still performant on an underpowered device or network even. You have 2G, down to completely offline if you want to see how your app does offline. So, and then you can, add your custom ones. But a lot of really, really cool stuff. You can also have, if you check screenshots, it's down here. If you check screenshots, it actually will. Let me do this. Let's do something. It actually will give you. You see in the timeline all these boxes. You see the. There you go. If you pause on them, it actually you see the counter incrementing as I'm going along. So Chrome will actually take screenshots of everything the window's seeing. So you it's just packed with really, really cool stuff. Is there anything specific someone has a question on regarding these tools or what they can do that they haven't seen yet that they might want to see? Yeah, Jesse. Yeah, and what it feels like is really the most important thing. Like I said, sometimes an operation might actually take longer in milliseconds, but it feels faster to the user, and that's what's important. Speaking of React, I'm actually glad you mentioned that because I forgot to say this. Has anyone ever heard of the work they're doing on React Fiber? What that is? Okay, so the React project announced they're working on a new rendering engine, which is called React Fiber, and the way that that works is under the hood, it uses request animation frame. So they're trying to, for work that can be delayed to when the browser is ready, which is really like a handful of milliseconds realistically, they're putting that in a request animation frame so it can be rendered on the page in a non-blocking way to speed up React. So other projects are doing this as well. So it's not just React that's doing this, but it's the one that popped out because they just talked about it at their React Conf. Okay, is there any more questions at all? One, yes.
So for memory debugging, a lot of times if I'm trying to like profile a page or snapshot or something, a lot of times a lot of objects that I don't understand where they're coming from.
Right.
Some library. Or if you had any.
Yeah. Let's see. Oh, what we didn't see snapshot. The question was if you're trying to debug a memory leak, how can you determine where the objects are coming from? And I believe in the profile, if you do a profile snapshot, you can inspect what's in memory, and then you can also see where it came from. I'm going to confirm that here. I'm not exactly. There we go. Allocation profiles show memory allocations from your JavaScript functions, so you can record an allocation profile. I'm going to start that, and then I'm going to run this function, and then I'm going to stop right now. And then we get, we kind of get the question. We kind of get the answer to your question. So you can dig in, however far down with corresponding function names and lines and stuff to see everything that's happened. So kind of where most of the memory usage is, append, and that's our append, function there. So, and you can really drill down to see exactly. And this will go through a bunch of React stuff, because I included React, so React's got a lot of steps through their dispatch cycle. So I'm not going to go through it all here, but you can drill down in these in the profile tool. Any other questions? Yeah.
I just wanted to share a fun trick.
Sure. You want the?
You showed earlier that you can use jQuery to change, for instance, the content of a tweet. If you go into the console and type document.body.content editable equals true, then you can just go edit the text directly in the page.
Nice. All right. Anyone else? All right. Thanks for coming, guys. Appreciate it.